Welcome friends to this engineering mathematics session. So many students were waiting for the practice sessions of engineering mathematics. Yes, we know that engineering mathematics is going to be very important for our upcoming GATE examination as well as ESE 2023, both examinations, right? Yes. So therefore we are coming up with engineering mathematics sessions for all the students. तो जो भी स्टूडेंट्स हैं सबको पता है कि गेट और ईएससी में मैथमेटिक्स का वेटेज काफ़ी ज़्यादा होने वाला है. यस, अगर हम सिर्फ गेट देखें तो वी कैन से 13 मार्क्स. यस, 13 मार्क्स इन योर गेट एग्जामिनेशन. यस, वी ऑल नो दिस, हमें पता है, बट स्टिल माय जॉब इज टू रिमाइंड ऑल्सो. यस, एंड ऑल्सो इन योर ईएससी प्रीलिम्स. यस, normally what happens when you're preparing for such examinations, we forget that for ESE prelims, we will be asked around 13 questions. Yes, and these 13 questions, ladies and gentlemen, yes, will be comprising of 26 marks, or I can say at least 20 to 26 marks will be from where? From ESE prelims of your mathematics. And therefore we are going to conduct these sessions for all the students, and today we'll be seeing what? Vector calculus. In vector calculus, there are three terms which are very confusing for many students. What are the three terms? Gradient, curl, and divergence. Yes, so we'll be dealing with these three terms. Okay, so this is a short introduction about myself. You can go through this introduction. Yes, I have done my BTech and MTech both from IIT Kharagpur. Yes, also I got selected into many of the PSUs through GATE only. Yes, and then I have worked with Delhi Metro. Yes, and I have been teaching in the field of GATE and ESE for the last 10 years. So let us start the session, but again some more announcements, some small announcements are there, okay, to keep you updated about the latest happenings on our channel. So from 3rd of January, okay, we know that in this channel we conduct a lot of series, yes, for the upcoming examination. So from 3rd of January we are coming up with this mega Maha Marathon. Okay, Maha Marathon means what? In one day we'll be revising one full subject. Okay, that will start from 3rd of January. The schedule will be out on 3rd of January. So please stay tuned to the channel. If you are not subscribed, please subscribe to the channel, right? Next we have on 1st of January an important session, okay, some strategy video, yes, to be taken by Dheeraj sir. Okay, so he'll be taking this session on 1st of January, but this will be on the BYJU'S Exam Prep app. This will be where? This will be on the BYJU'S Exam Prep app, and it will be in the afternoon 12:30 p.m. Okay, so we'll start the session in just 1 minute. So I'll request the students to just wait for 1 minute. We'll start the session in 1 minute. Oh, welcome back. I just reduced my size. I was looking huge, so we'll start the session. So I just reduced the size. So now the size is fine, right? So welcome Prathamesh, Saurabh Sri, Vivek, Jayas, Survi, Diya, Swapnil, Naman, Juhi, many students. Okay, we'll start the session today. I'll just see that everything is fine or not. If everything is fine, just once write that everything is fine, and then we will start the session. Okay, please write once that everything is fine. So this is fine. Welcome Surendra Singh Solanki. Welcome. Okay. Yes, everything is fine. So why my okay, there is some problem with my mobile, therefore it is not coming. Some problem with the internet. No, now it came. All fine. So we'll start the session. तो सेशन को शुरू करते हैं. दो सेशन जो है वो दोनों ही भाषाओं में होंगी. It will be in English and Hindi both. Okay. In public demand. Okay. Now first of all, when we are studying this vector calculus, okay, I'll introduce a particular operator. This is known as what? Del operator. We call this as what? Del operator. Now what is this del operator? This del operator is actually a vector. Okay, it's actually a vector. So del operator is what? Dou by dou x I cap plus dou by dou y j cap, yes, plus dou by dou z k cap. So this is the del operator. This is the del operator. क्या है ये? Del operator है. Now ये operator तो obviously it will operate on something. It can operate on something, right? Now it can operate on something. It can operate on something. So it can operate on a scalar function. It can operate on a scalar function. Now scalar function क्या होगा? What is a scalar function? Which is not a vector, right? Which is not a vector. तो scalar function कैसा होगा? मान लीजिए I am telling x square y cube z plus suppose I am telling y z square. This is a scalar function, right? It is a function of x y z. You can say this is a function of x y z, but it is a scalar function. Means what? There is no direction to this. There is no direction. Now what will be a vector function? What will be a vector function? The vector function will have direction. Means what? Suppose I am telling capital F and then to indicate a vector like this. So this will be what? Suppose I am giving x y square z I cap plus y z cube, suppose j cap, yes, plus suppose x cube y k cap. So I can say this capital F is what? It is a vector function. Why? Because it has got direction. It has got direction. Whereas this one is a scalar function. So everybody understood what is a scalar function, what is a vector function. Easy, very easy. Now, when this del operator, which is itself a vector, it acts on either a scalar function or vector function in some way, then curl, gradient and divergence will come into picture. So first one we will see is gradient. First one we'll see is what? Gradient. Okay, gradient. Gradient. Now gradient means what? I denote like this. Gradient I denote like this or I denote like this. Now first of all, gradient operates on what? Means this gradient operates on what? It operates on a scalar function. So gradient, okay, operate on what? I can say this operates on a scalar function. तो किस पे लगेगा? एक scalar function पे लगेगा. एक scalar function पे लगेगा. Operates on a scalar function. Yes. Suppose I am giving example of that scalar function is, suppose I am giving example x cube, x square, y cube, z. It's a scalar function. It's a scalar function. Now I am telling that gradient of f. Now in place of gradient, what I can write down? Dou of dou x, yes, then I cap plus dou of dou y, then j cap, then dou of dou z, k cap. It's a vector. It is a vector. Now it is operating on f, means what? This function. So what I can do? I can take this f inside, na? I can take this f inside. When I take the f inside, what will happen? Dou f by dou x, right? Then dou f by dou y and dou f by dou z. I get this thing, right? Now tell me, this is a vector or scalar? Now tell me, this is a vector or scalar? Please write in the comment section, this is a vector or scalar. This thing which we got, it is a vector or scalar? Please write in the comment section. It is a vector or scalar? It is a vector or scalar? Please write in the comment section. क्या है ये, वेक्टर है या स्केलर है? जो निकल के आया ये वेक्टर निकल के आया. क्या निकल के आया? इज अ वेक्टर. That means what? That means what? That gradient operates on a scalar function. Yes, it operates on a scalar function and gives what? And क्या देता है? And gives what? It gives a vector. It gives a vector function. And these are what? Partial derivative of f with respect to y, sorry, x, partial derivative of f with respect to y, and then partial derivative of f with respect to z. Yes. So हम अभी क्या किए? Gradient क्या हुआ? तो एक f function था. There was an f function. And this f function was what? Scalar function. Yes, this f function was what? Scalar function. Okay. And then when we did gradient of f, or I can say what? Like this. I indicate like this. Gradient of f, I indicate like this. Okay. This converts into what? This converts this into what? A vector function. It converts into a vector function. And how to find out the vector function? How to find out that vector function? Very easy. Differentiation of f with respect to x, partial differentiation, I cap, plus differentiation of f with respect to y, partial differentiation, j cap, plus differentiation of f with respect to what? Z, k cap. Very easy, yes or no? Very easy. This is what? Gradient. This is what? Gradient. So gradient always acts on a scalar function. Easy. And gives a vector function. For example, suppose f, I am telling, I just told now this example, x square y cube z. X square y cube z. This is the scalar function. Now if I want to convert this into a vector function, I want to convert into a vector function, what I will do? What I will do? I will take the differentiation. Now tell me, what will be the vector function when I do this gradient? Give me the vector function. Chalo, give me the vector function. I cap, what is with I cap, what is with j cap, what is with k cap? You differentiate and give me. Partial differentiation. Partially differentiate and give me. Chalo, you give me, chalo. What I will write with I cap, what I will write with j cap, and what I will write with k cap. Differentiate with partially and then give me the answer. Chalo, give. Fatapat. We'll solve more questions, don't worry, but it's the starting. Please write the answer. For I cap, what is the answer? For j cap, what is the answer? For k cap, what is the answer? First differentiate with respect to x. When we differentiate with respect to x, I will get what? 2x y cube z. Only x will change. Other things will remain constant, right? Other things will not be affected. Okay? Then keep on writing, don't wait for me, keep on writing. I, J, K, keep on writing, be active. Okay, be active. Okay, come on, keep on writing, yes. Okay, Yadav has told, good answer. So this is what? If you differentiate f with respect to y, what I will get? 3x square, then y square, z. And last term will be what? Only x square, y cube. So everybody understood, right? Everybody understood. So gradient converts a scalar function into a vector function. Easy. They will give you a scalar function like this. They will ask you the vector function. If you know differentiation, but partial differentiation, do partial differentiation. If you do the partial differentiation, yes, then you can easily get the answer like this. Yes, easily get the answer. This is what? This was what? This was gradient. Let us go to the next thing. The next thing is divergence. The next thing is what? Divergence. Now remember everyone that gradient acts on a scalar function. Divergence and curl acts on a vector function. Divergence and curl acts on a vector function. Very important. Divergence is what? Now del operator is a vector itself, now. Yes, del operator is a vector itself, right? Del operator is what? It is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. So del operator is itself a vector. So I can take the dot product of this with any vector. Yes. And I can take a cross product of this. Yes or no? I can take a cross product of this. So very easy. So divergence is nothing but the dot product of any vector. Okay. Any vector with f. And what is curl? Curl is the cross product of any vector with this del operator. Understood difference? Clear now? Very easy. Very easy. If you remember, what was gradient? Gradient acts on a scalar function. Yes. But here the divergence and curl, they're acting on what? Vector function. The divergence is what? It is dot product, and curl is what? It is cross product. Now tell me, the dot product of two vectors gives me what? The dot product of two vectors gives me what? The dot product of two vectors gives me what? Tell me. Dot product gives me what? Tell me. Write in the comment section. Dot product क्या देता है? दो वेक्टर का क्या देता है? बताओ. These are all childhood things. Yes, it gives a scalar. So this, ladies and gentlemen, will be a scalar. It will be a scalar, right? And cross product. What cross product gives me of two vectors? Two vectors cross product is also a vector, na? Yes, it's also a vector. Yes, so divergence will give me a scalar thing and curl will give me a vector thing. Yes, easy, so easy. Now if I summarize all the three, I write down gradient, I write down next is what? Next I will write down divergence, and next I will write down curl. Three things. Yes. Now everywhere del will come into picture, or everywhere del will come into picture. Now first of all, if I say your gradient, if I say what? The gradient, it operates on what? Tell me. Fill this. Operates on what? Gradient operates on what? Tell me. Gradient operates on what? Fast. You should speak fast. Gradient operates on what? Gradient operates on what? Fast. Slow है बाबा. Gradient कहाँ तुम्हारा? Scalar. Vector कहाँ लिख रहा है? हाँ? Why writing vector? हाँ? No vector. Gradient acts on a scalar function. Remember, it acts on a scalar function. Whereas divergence and curl both act on vector function. Okay, and then what is the end product? When we do gradient, what is the end product? The end product is a vector in case of gradient. In case of divergence, it is a scalar. Right? And in case of a curl, it is again a vector. Because curl is what? Curl is just the cross product. And divergence is what? Divergence is just the dot product. So dot product will give me scalar, right? And gradient is what? The del operator acting on f. Everybody is clear with this table or not? Tell me. Everybody is clear with this table or not? If you are clear with this table, then we will go to questions and more conclusions about this. Everybody is clear about this or not? Tell me. Everybody is clear? Clear? Let us start solving questions. We'll solve some questions, and then we will be seeing some more conclusions which can be asked in these three things. And at the end, we will be going into directional derivative also. Very simple, straightforward. So I'm giving you a question which was asked in Civil 2017. Very simple question I will give you. That the vector function is given as x square I cap plus 2y cube j cap plus z to the power 4 k cap. Given very straightforward question. Okay. At 1, 2, 3 means what? X is equal to 1, y is equal to 2 and z is equal to 3. We are asked to find out the divergence. We are asked to find out what? Divergence. Obviously, a vector is given. Why? Because divergence acts on what? It's action a vector only, right? So very easy, very easy. No need to remember any formula. Just remember that divergence is what? The dot product of these two vectors, right? Means del operator and this vector v. This is the divergence, right? Khatam. And this del operator is what? It is dou of dou x I cap plus dou of dou y j cap plus dou of dou z k cap. Now we know that when we are doing dot product, see, we know that when we do the dot product, okay, we know that whenever we do the dot product, yes, I dot I is what? 1, na? Yes. J dot I is what? 0, na? Yes, because I and j are perpendicular. So what is dot product? Dot product is I j cos theta. And cos theta will be what? Cos 90, because I and j are perpendicular. Cos 90 is 0, right? Even your I dot k is 0, right? And jk dot k is 0. So what you will do? You will just do what? Tell me. You will just do what? This into this. Yes. I can say this into this. Yes or no? Or I can say that this will be nothing but, nothing but what? The partial derivative of x square with respect to your x. Yes. Means I cap and I cap. That is how we do dot product, right? Childhood you did. Yes or no? Then j and j. J and j. So what this will be? This will be the partial differentiation of 2y cube with respect to what? Your y. And then k dot k. K dot k, so we'll multiply this 2, right? So what will happen? Partial derivative of this term with respect to z. This everybody understood or not? Or if I elaborate it, many students might not be knowing. Let me elaborate it. What was the equation? X square I cap plus 2y cube j cap plus z to the power 4 k cap. Yes. Dot what? Dou of this I cap, then j cap, and then k cap. So when you do this, when you do the dot product, what will happen? This will get multiplied, right? This will get multiplied, and this will get multiplied. Yes, you cannot multiply I and j. You can do that. When you do I and j, what will happen? I dot j will be what? 0, na? Yes. Or j dot k will be 0, na? So what will happen? You can only multiply what? I dot I. Because I dot I is what? I dot I is what? The magnitude of I, both I, then cos 0, because I and I in same direction. That will be what? 1 into 1 into 1. I'll get a 1, right? I'll get a 1. But if I do I dot j, I'll get a 0. Understood? This all things you have studied in childhood but might have forgotten. Understood? So now tell me, what is the answer now? If I differentiate it, I get what? 2x. This will be what? 6y square. And this will be what? 4z cube. Now put these values. This is x, this is y, and this is z. Put these values and give me the answer. Very simple. Very simple. Now see, first of all, tell me, this is a scalar function, na? This is a scalar function, na? Yes or no? So that's what divergence does, na? Divergence acts on a vector function and converts into what? A scalar function. Now the value of the scalar function, it is asked, right? The value is asked. They can ask the expression also, they can ask the value also. So very straightforward question, right? So what is the answer? Just put the values and give me. I am not solving for you. 2 into 1 plus 6 into 2 square and then 4 into 3 square. So getting 134. Understood everyone? Very straightforward question on divergence, right? Very straightforward question on divergence. Let us solve some more questions. The next question is, I have all the questions here. I didn't type the questions, so I thought that I'll write the questions. Anyhow, my handwriting is good. Yes. So find out this, okay? This is Mechanical 2017. Okay. First we'll start with basic things and then we will go to little difficult things. Don't worry. Suppose this is the function. This is the function. It is asked to find out the divergence of this. Divergence. Find out divergence of this function. Again, it's a vector function, right? To find the divergence of this function. It's a one more question, very straightforward. What's the divergence of this function? Tell me. Very straightforward thing. Very straightforward, easy. X minus y or 0? See, do this. Right? So this is what? Dou of dou x of what? I cap plus dou of dou y of j cap plus dou of dou z of k cap. Yes? This dot product of what? Minus y I cap plus x j cap. That means what? You will differentiate this with respect to x. Partial differentiation of this with respect to x will be what? 0. And partial differentiation of this with respect to y will be what? 0. So answer is what? Straight 0. So divergence is straight 0 here. Very easy question. Very easy question. Okay. Let us solve another question. So we'll be solving a lot of questions now. Okay. Let us go to some gradient stuff, right? So I will asking you gradient now. Okay, I'll ask you a gradient. Okay. So the gradient will operate on a scalar function. The scalar function is given as xyz is equal to 3x square y minus y cube z square, right? We have to find out the gradient of f. This is gradient of f, right? See, sometimes they will not write gradient of f. They might ask, they give you the expression. You should know that this is gradient of f. So you have to find out the gradient of f. So obviously options will be vector, right? The options will be vector now because gradient converts a scalar function into vector function, right? So directly I am giving you that find out this at 1, 2, 1, minus 2 and minus 1. Okay, you have to find out this. Okay, so the answer will be a vector function only. The answer will be vector function only. Suppose I cap plus some j cap plus some k cap. So tell me the answer. Okay, find out gradient of this. Okay, I find out this answer. So this is the scalar function. You have to this gradient will convert this scalar function into a vector function. Okay. If you're getting confused now, if you just remember this is what? If you just remember this now and you know what is the operation, then also you can find out. So I am not writing very complicated equations. Okay, by simple things I am solving the questions. This is operating on a scalar function. So what will happen? Just bring this f here, right? The f is outside now. See, this into f. So bring it inside, right? So f. Game over. Yes. Chalo. Give me the value. Minus 12i. Okay, let me see other things. So I differentiate with respect to x. I will get 6xy I cap. Differentiate with respect to y. I will get 3x square minus 3y square z square, right? J cap plus different respect to z I will get minus 2z y cube k cap. This is the vector I get. Right? This is the vector I get. Okay. So now you have to just put the values 1, minus 2 and 1, minus 1. So first term will be obviously minus 12. Second term will be 3 into 1 minus 3 into 4. 3 minus 12. I'll get minus 9. Here, right? The third term will be minus of 2 into, this is minus and then 2 cube, 8, 16, minus 16 I am getting. Why everyone is so slow? Ladies and gentlemen, you forgot differentiation. Partial differentiation forgot. Partial differentiation forgot or what? Huh? Huh? Why you are taking so much of time for simple things, huh? X, Y, Z, right? X, Y, Z. Got everyone? Clear? 16? Now clear. Taking so much of time. Now solve this question. It was asked in Civil 2009. Okay. Now solve this question. Okay. So giving the function, f function is x square plus 3y square plus 2z square. Yes. You have to find out the gradient of f, okay, at 1, 2 and minus 1. Now solve this very fast. Now solve this very fast. I cap plus j cap plus k cap. Solve this very fast. Gradient of f. Fast, very fast. So gradient of f, first you write down the del operator. Dou of dou x I cap plus dou of dou y j cap plus dou of dou z k cap. Then it is operated on f. So just take the f inside. Just take the f inside. Yes. 2, 12 and minus 4. Very good. So now you have gained the speed, right? So if you differentiate with respect to x, this was easy, nah? Therefore you solved very fast. Otherwise you are taking so much of time and committing mistakes. Okay, so this was the function I can take. Yes, I just put the value. So 2 and then 12, right? And then minus 4. This is the answer. Very simple question, right? You just need to know the operations. Now let us solve one question from curl also. Let us solve one question on the curl. So curl means they will give you what? A vector function. Obviously they will give a vector function. So let me write down the vector function x square z square I cap, okay, minus 2xy square z j cap, okay, plus 2y square z cube and then k cap. Let me just check. 2y squared z cube and then 2xy squared z and this. So they will give you a vector function because curl will act on a vector. They might write curl of f, okay, they might write curl of f, or they might give this notation, right? This notation is what? This notation is curl of f, the vector, we can say cross product. Now how to do this cross product? How we do cross product? Very easy, na? You see, it's very easy. It's a determinant of what? I, j, k. Okay, just write like this. Then what? Then first what is coming? Del operator is coming. Now what is del operator? Dou by dou x I cap, dou by dou y j cap, dou by dou z k cap. First del operator is coming, so first write down this del operator thing. Then f. If you see f, what is the x component? It is what? X cube z square, right? Yes. What is the y component? Y component is minus 2xy square and then z. What is the z component? The z component is 2y square x cube, z cube. I'll just give some more space here, otherwise looking very clumsy. So I, j, k, dou by dou x, dou by dou y and dou by dou z. Easy. And this is what? X square z square, then minus 2xy square z, and last one is 2y square z cube. Now to just find out the determinant of this. This is how we find out what? The cross product. Okay, x square, huh? Yeah, x square, na? I put x square, na? Yes. Okay. Now this is how we write down. Write down systematically. Write down systematically. No hurry. If this question is asked, I will give you 2 marks. So do systematically, get 2 marks now. 2 marks for 3 minutes you can take easily to solve this question. Now first you write down what? I cap. Write down I cap. Then what will happen? We do this, na? I cap we do this, na? Eliminate, finally determinate. Yes, I am making you remember your old age. Yes. So then what? I can say the partial derivative of this term 2y square z cube, okay, with respect to y minus what? Minus the partial derivative of this term, okay, with respect to what? Your z. Yeah, this is I cap thing. This I cap thing. Yes, I cap thing. Yes. Now can you tell me what is coming? Let us first find out the I cap thing, then we'll go to j cap, and then we'll go to k cap. So what is this term we are getting? First a difference with respect to y, you're getting what? 4y z cube, and then minus minus I'll get a plus here. Difference with respect to z, I am getting what? Plus 2xy square, na? Is this term for I cap? Yes or no, ladies and gentlemen? Am I getting this term for I cap? Yes. See, I can just solve and go. I am solving for you. You have to also solve, okay? You solve with me, don't see this. See, mathematics is, see, one thing understand. Mathematics don't see like a movie. You have to do yourself, okay? Otherwise, when I am doing, everything will look nice. When I am doing, everything will look nice. When you do, you'll commit mistakes. So 4yz cube plus your 2xy square I cap. So first I did with the I cap thing. Nice. Okay, somebody found out also. Okay. Next, let us go to what? J cap. Let us go to what? J cap thing. So when I go to J cap thing, what will happen? So I will eliminate these two things, now this row and this column, right? Then what I will do? Then this I will do, right? Yes. But here with a minus sign, because that adjoint theory will come into picture. So minus j, okay, somebody found out x, let us see the j also. For j, what will happen? Partial differentiation of this term 2y square z cube with respect to x minus partial differentiation of this term, which one? Your x square z square with respect to z. Yes. Now when you see here, there is no x thing. So what will happen? The differentiation will be what? Straight 0, na? This partial difference will be straight 0. And this partial differentiation will give me what? 2xz, right? It will give me 2xz, 2x square z actually, right? With a minus sign, of course. And we have already a minus sign, so it will become what? Plus 2x square, okay, 2x square z j cap. Understood everyone? 2x square z j cap. Everybody understood this thing or not? Tell me. Everybody understood this thing or not? Okay. So I'll get 2x square z j cap. Easy. Got is or not, Baba? Clear? Okay. Now give me the k cap then. Similarly, give me the k cap then. You give me the k cap then. Chalo. You give me the k cap. You give me the k cap. Cancel this, this. Do this. Chalo, karo. I couldn't see the comment of Yadav. Let me see. No, that minus sign will become plus now because minus j. I think last term also some problem is there, k. Otherwise first term is fine, but you just made it minus. That minus will become plus now. How much are you getting? Minus 4 you're getting, huh? Minus 4. Sir, MIT Manipal, I don't know. I don't know about MIT Manipal, sorry. Okay, let us solve this question. Let us solve. So differentiation of minus 2xy square z with respect to x minus differentiation of x square z square with respect to what? Your y. So see, this term will be 0 na, because there is no y term, so partial difference will be 0. Now you consider this term. What will be this term? What will be this term? The difference will be what? Minus 2y square z, na? Yes or no? Differentiate with respect to x, na? Understood? So minus 2y square z I am getting. Yes, that is the answer. Everybody got? I saw many people got also. Let me see who all have got. Very good. Kartigai also got. Arun also got. Akshata also got. Very good. Very good. Okay. Very good. So this much KCAP. See, when they ask you curl, na? See, when they ask you curl, it is simply what? It is simply your cross product. But you have to do it little systematic. Okay. Do it little systematic. If you do it very systematic, then you can easily find. And you can see that this is a vector function. ESE paid batches. I complete many subjects actually. Okay. Okay. Everybody understood? I take all the civilian subjects, actually many subjects, depending on the schedule and all we take. Okay. Anyhow, in the learn with video lessons, I have recorded strength of materials, fluid mechanics, geotech, environment. Okay, many things I have taken. So curl, everybody understood or not? So we solved three type of things, right? Okay, three types of things. This is what? Gradient of f. This is what? Divergence of f. But this will be a vector function. And this is what? This is a curl of f. This is a curl of f. Gradient. This is what? Divergence. Okay. And this is curl. This is curl. Now, let us see some conclusions which are very important. Let us see some conclusions which are very important. Now, tell me this. What is this? This will be a vector or scalar? Tell me. This will be a vector or scalar? Tell me. This will be a vector or scalar? Whatever I have written, it's a vector or a scalar? Whatever I have written, it's a vector or a scalar? It is a vector. It is a vector. Okay? Because f is a scalar and I am doing gradient of f. This is what? Actually AR. I am doing gradient of f. Yes. So gradient of f will be what? It will be a vector. It will be a vector. Now, if this is a vector, I can do this one. Na? Can I do this one? Can I do this one? Okay. Can I do this one? I can do this one. This will give me what? Tell me. Because this is now a vector. This is now a vector. Yes. This is now a vector. Yes. I am taking a dot product. So I will get what? I will get a scalar, right? I will get a scalar. Yes. Can I write this edge? Can I write this edge? Divergence. Can I write this edge? Divergence of gradient of f. Yes or no? Can I write this as divergence of gradient of f? Right? Yes. So divergence of gradient of f will give me a scalar. Yes. The divergence of gradient of f will give me a scalar. Such kind of questions they can frame. Such kind of questions they can frame. Everybody understood how to solve? This will be 1 mark questions. If they ask you such questions, it will be 1 mark questions. Easily you can solve, right? Easily you can solve. Yes. Now, something more. This divergence of your gradient of f is also written as del square f. It is also written as what? Del square f. Also written as what? Del square f. How? Suppose I am writing, I am writing, suppose f function is, suppose I am writing x square, then y, and then zq. Suppose I am writing a function, scalar function, right? So when I take the gradient of f, so what will happen? This will be the partial differentiation of del f by del x. Don't solve. Then I cap. Then del f by del y j cap. Yes. Plus del f by del z k cap. Yes. Now when you do the divergence of this gradient of f, that means what? You will take this vector, okay, this vector, yes, and then operate the del operator like this, dot product, yes. Or it will come on my back, so I'll write down here. Del operator is what? Del of del x I cap plus del of del y j cap plus del of del z k cap. Then I'm taking what? Dot product with what? Del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So it came in behind me, so I'll just turn like this. Understood? Okay. Okay, so Mr. Anuj Kumar. Once more you write this, I will tell to block, okay. Once more you do this kind of disturbance activities, I'll straight away block, okay. Understood? Now see, now this is dot product na. Now this is dot product. Now this is the dot product, then what will happen? Only I will operate na, and then J, and then what? KK, then KK, right? So when you see, when you operate this on this, this becomes what? Double derivative of f with respect to x, yes or no? Then double derivative of f with respect to y, yes, and then double derivative of f with respect to z. Yes or no? Everybody understood this thing or not? Tell me. Everybody understood this thing or not? Tell me. I'll just shift this side. Okay. Now tell. Understood this thing? Important thing. Clear? Clear? Very good. Clear? Very good. So I came back. Okay. So remember this thing. Remember this thing. The del operator dot del f, which is what? Divergence of gradient of f, which is denoted as del square f, is nothing but what? Del square f by del x square plus del square f by del y square plus del square f by del z square. Easy? Easy or not? See these things? See, these things just look difficult because we are not approaching this thing systematically. See, mathematics has to be approached very systematically in a calm and composed manner. Okay. If you approach this very systematically, you can see that by the end of this class, you would have understood, mastered very difficult things which you used to feel difficult before, but now they will be very easy. Now they will be very easy. Now, let us go ahead and solve one question. So, a phi function is given. Phi function is given. That is what? 2xx cube y squared z to the power 4. This was asked in GATE 2014. Okay, GATE 2014. Okay, this is a scalar function. This is a scalar function. Now, what is written? Del square phi. Find out del square phi. Now, tell me del square phi is written. So, this will give me which kind of function? Vector function or scalar function? Tell me. Del square phi will give me vector function or scalar function? Tell me. Del square phi will give me a vector function or scalar function? Scalar function, yes, because this is nothing but what? Divergence of gradient of phi. Are nothing baba, In place of phi, in place of f, it is given phi. See, in place of f, it is given phi. That's it. Yes. So now, this is nothing but what? This is nothing but del square phi, okay, del a square plus del square phi del y square, okay, plus del square phi del z square. Yes. So differentiate phi with respect to x, differentiate phi with respect to y, two times, double derivative, double differentiation. Now can you give me the answer, final expression? Give me the final expression. So come on, solve this question. Very straightforward question. Please solve this question and give me the answer. Come on. Fatafat. Give me the long expression. A long expression will come, na? First I will differentiate this. For first time I will differentiate, so it will become 6x square y square z to the power 4. Again I will differentiate, it will become what? 12x y square z to the power 4. Then I'll differentiate 2 times with respect to y. So 4y, 4x cube z to the power 4 after 2 times differentiation. After 2 times difference in respect to z, it will be 8, then 24. Yes, I am getting this term. Are you getting this? I am writing here the answer. Let us see. Arsenal, very good. 4, very good. Very good. अरे ये क्या निकाल दिया विवेक? Okay, first, okay, हाँ, that term is correct, good. Got same, very good. Understood? Yes. So I can say that these things are very easy if you understand the notations. Yes or no? The notations are difficult to understand, but if you once understand these things are not difficult. So everybody understood this thing, right? The divergence of gradient of f. The divergence of gradient of f is what? The double derivative of f, like this. Clear? Everybody understood this? Shall we move to the next thing? Everyone is clear with this particular thing? Divergence of gradient of f. Clear? Very good. Let us go to the next thing. Now tell me. This is a vector function, na? This is a vector function. So I can take a curl also, na? I can do a cross product. Vector. This I can say is what? Tell me, what is this? Can I say this is curl of gradient of f, na? Yes or no? Can I say this is the curl of gradient of f? Yes or no? Please tell me. I want to see that yes thing, then I will proceed, because these things are complicated. I don't want to rush through things. Okay? Okay. Curl of gradient of f, na? Yes. Very good. Now see, I will write this f function. When I write this expression is what? This expression is del f of del x I cap, then del f of del y j cap plus del f by del z k cap. Very good. Now see, this is curl, na? Curl of this one. Now curl of this one will be what? curl of this one will be, I'll write down here. This is also a vector now. So curl of this will be what? I'll find out the curl. I, J, K. Yes. First I'll write out del operator. So del by del X, then del by del Y, then del by del Z. Nice. Now what is this? This is what? Del F by del X, then del F by del Y, and then del F by del Z. Actually dou, actually we call it dou, partial differentiation. I am using del's, sorry, it is still dou, it is partial differentiation. Now when you do this find out determinant, what will happen? For I cap you will do this stuff, right? So what it becomes? Del square F by del Y del Z, right? Yes, minus del square F by del Y del Z. Ooh. Then plus J of not plus, minus J of this na, del square F by del X del Z, okay, minus del square F by del X del Z. Ooh. Okay. Okay. Plus K of this, then this. So what? Del square Fi del X del Y minus del square F by del X del Y. Everything is getting cancelled. Right? So I can say that this expression which is what? Curl of gradient of F is 0. But now tell me, when I say curl of gradient of F, yes, this is what? Curl of gradient of F. No doubt it is 0. We got 0. But it's a vector or it's a scalar? It's a vector or it's a scalar? That 0 is a vector or 0 is a scalar? Tell me. That 0 is a vector or 0 is a scalar? That 0 is a vector or is a scalar? It's a vector. It's a vector. Why? Because gradient of F will give me what? A vector. When you do a cross product with another vector, vector cross product with a vector will give me what? A vector only, even if it is having 0 value. Therefore it is 0 I cap plus 0 j cap plus 0 k cap. Understood? So in examination they will ask you like this. They ask you in theoretical question 1 mark. They will give you this. They will give you like this. You see, 4 options they will give you. Yeah, HK Das is good. I like this Jain and Iyengar also. Jain and Iyengar is also good. But too many things are given there. So I will recommend at the end what to do. Don't worry. So what is the answer here? What is the right answer here in the given options? What is the right answer here? Come on, ladies and gentlemen. क्या इतना टाइम लग रहा है रे बाबा? सो के उठा है क्या? चाय वाय पी लो. have some tea and coffee, or go to washroom and wash your face and take a bath, whatever you are. What are you answering so slow? Huh? Yes, this is curl of gradient of f is 0 and it's a vector. Okay, now such kind of one more questions will be asked and we feel that this is very difficult, but actually it is not difficult, it is just conceptual. Now if you know the concept, you can solve this question in less than 1 minute. Yes or no? Tell me, this question is less than 1 minute question or not? Yes, it can be solved in less than 1 minute. I'll switch off the AC. Now it is very cold. I'll get cold and throat will do khich khich and then gale mein khich khich and I can't teach. So therefore we'll switch off the AC. Nice. Cool, right? Now tell me. So this one we understood. Next thing. Again I told that this is gradient of f. This is gradient of f. Okay. Now I can take, this is not gradient of f. See this one, this one. Suppose there is a vector f. F is a vector. So the cross product will give me what? This will also give me a vector, right? This will also give me a vector. If f is a vector, this will give me a vector. Now if I take a dot product, of del operator on this vector, okay, that will give me what? That will give me what? It will give me a scalar, right? It will give me a scalar. Yes, because a dot product. It's a dot product, right? It's a dot product, right? Now, this is what? Can I say this is divergence of curl of f, right? Can I say this is divergence of curl of f? Yes or no? So the divergence of curl of f, what is that value? Let us see. Let us see that. What is that value? Okay. See, there is a long method also. But I'll give you a very short method. Okay. I will give you a very short method also. You see, suppose this is the del operator. And this is the f function. This is f vector. Now they will be lying in a particular plane. Yes, they will lie in a particular plane. Yes. Now del cross f will be perpendicular to both of them, right? Yes or no? Del cross f will be perpendicular to both of them, right? Yes, because the cross product is perpendicular. We know this, na? Yes, right hand thumb rule. Remember? Yes, all we forgot childhood. When after childhood we forgot everything. So time to recall everything. So this will be perpendicular to both of them. That means what? It will be perpendicular to this del vector. Now, if you take divergence, means what? Del dot this. So what will happen? Can I say this will be equal to the magnitude of this, then magnitude of this into what? Cos theta. And theta is how much? Theta is 90, ladies and gentlemen. This is 0. Yes, because cos theta is 90. So this is what? 0. So I can say this will be 0, but this is a scalar. This is 0. I can say scalar. So that means you can see here, these expressions, they can ask you directly. Understood? Now, suppose I ask you a question, I ask you a question. Suppose I ask you a question that vector v is equal to, I am giving a vector v, I am going to be vector v. Answer. सो रहा है, पता नहीं क्या कर रहा है. What is the answer? Why you are even solving also? Why you are even solving? This is nothing but divergence of curl, na? Why you are even solving? Just in place of f I put v. So you are searching. अरे मैं इसका एग्जाम में f ही लिखेगा क्या? They can write g, f, k, whatever, ना? Yes, this is divergence of curl of v. This is 0. So answer is 0. Yes. So whatever is written in this vector function doesn't matter. Whatever is written in this vector function doesn't matter. Smart. Okay. See, here I have derived with f doesn't mean that in the examination they will give f only. They might write g, h, whatever, right? So understand this f is just a vector function. Okay. So you see such kind of questions they can ask. Everybody is clear now? Let us revise what you have studied till now. First of all, I studied that what is a gradient of f. Gradient of f is very simple. This f will be a scalar function. This gradient of f will be del f del x I cap, then del f del y j cap plus del f del z k cap. Easy. Easy. Okay. Okay. 30 to 50 seconds. Okay. Okay. Admitted. Then we have what? The divergence. Divergence acts on a vector f, right? So divergence acts on a vector f and it gives a scalar. And what is the expression? You can know what to do. Then we have a cross product. This cross product gives me what? The curl. This gives me a vector, right? So this gives me a vector. This is a curl. This is curl and this is divergence. The first one was gradient. The first one was what? Gradient. Okay, very good, interesting, nice. Then we saw some identities. See, all the identities I have not derived. Okay, there are many identities. I have derived first three. The top we can say three very commonly asked or frequently asked. First one is what? That this is gradient. This is gradient, right? And then dot means what? The divergence of gradient of f is equal to what? Del square f. And obviously this will be a scalar. Obviously this will be a scalar because this becomes vector. Vector dot vector will be a scalar. Now second thing we saw is, second identity what we saw, that if you take the gradient of f and you do what? If you turn not gradient of f, if you do a cross product, right? This was dot product, right? If you do a cross product, then what will happen? This I will get a 0, but this will be a vector because vector cross vector will give me a vector, right? The third thing I told that if you take, this was what actually, this was curl of gradient of f. Okay. Now third thing I told what? You take the curl of a vector function and then take the dot product. So what will happen? This is vector, dot product. This is 0, but this is what? Scalar 0. Because this is dot product of two vectors, right? And this is what I can say, this is divergence of curl of a vector function. Clear? Clear? These things we have studied till now. Let us see some more conclusions. Okay. Now, if the divergence is 0, if the divergence, okay, if the divergence is 0, okay, of a divergence of obviously vector function because divergence acts on a vector function only. If it is 0, then I call that particular function as what? Incompressible. Yes, you might have seen these things in your fluid mechanics. Incompressible. We'll not go into the fluid mechanics or for electrical engineer. It is solenoidal, right? Solenoidal, right? We'll not go into the, we can say, physics of this because that will be confined to what? Those branches. But this either fluid is incompressible for fluid or for electric fields, we can say it is solenoidal, right? And when the curl is 0, that means what? It is irrotational. It is what? It is irrotational, right? So divergence means this one is 0 and curl means this one is 0. So based on this, lot of questions are asked. Let us solve those questions. Based on this conclusion, some questions are asked. Let us solve those questions. Okay. Now suppose we have a vector p is equal to x square y I cap minus x square y square j cap, okay, minus x square y z k cap. Let me just recheck x cube y x square y square and then x square z. Okay, ladies and gentlemen. Now tell me about it is solenoidal or not, okay, and it is irrotational or not. Check. Suppose I am giving option A as what? Like this, right. Option B as wrong, right. Option C as wrong, and option D as right, wrong. So give me the answer to this. This was asked in GATE 2016. B. Others. Okay, take your time. Check the divergence of this function and then tell the curl also of this function. Let us find a divergence. If I find out divergence, first differentiation of this respect to x, so 3 x square y minus 2x square y minus x square y. See, the divergence is coming 0. Now, yes, the divergence is coming 0. That means it is solenoidal, right? Just that means it can be either A or D. I have to check it is irrotational or not, right? I have to check it is irrotational or not. So I will just check it. I, J, K. Solve it systematically. Find out the curl systematically. No hurry. Del of del x, del of del y, del of del z. Very calm and quiet you solve. 2 more questions. 3 minutes is there. No hurry. X square y, then x square y square, then x square z. This is y z, na? This is a minus sign, right? Let me just recheck. Yeah. Now, so I cap, then I can say differentiation of minus x square yz with respect to y, then minus differentiation of minus x square y square with respect to z. This is for I cap. For I cap, how much I am getting? Minus x square z. I am getting minus x square z, na? Minus x square z I cap. So you see, only if I component is not 0, see, if I component is not 0, that means there is no need to find out j and k, na? Even if j and k are 0 and I component is not 0, still it remains what? Still it remains non-zero, na? Understood this point or not? Understood this point or not? Yes. So curl is non-zero. So the curl, this is what? Curl of the p vector, or I can say this curl of p vector is non-zero, because there is no point to find out the j and k component, because if I component it itself not zero, there is no point in finding others, because even if they are zero, it's still not a zero vector. Understood? So it is non-zero. So non-zero means what? It is this one, right? So it is solenoidal but not irrotational. Not irrotational, or I can say rotational. Yes. Understood? You can solve this kind of questions, yes or no? You can solve this kind of questions. Now very easy question was asked. Very easy question was asked. See this. B is given a1x plus a2y plus a3z I cap, okay, plus b1x plus b2y plus b3z j cap plus c1x plus c2y plus c3z k cap. Okay. Now what is asked? If the vector field is incompressive, so the vector field is incompressible, okay, and a1 is equal to 2 and c3 is equal to -4, find b2. Very easy question. Solve this. Find b2. चलो फटाफट solve करो. Solve this. Two. Very good. See, incompressible means what? Your divergence is 0. Divergence is 0 means what? You will differentiate this term with respect to, see, you will see, divergence means what? This dot this. Yes. So this is what? Del by del x I cap plus del by del y j cap plus del by del z k cap. So when you do a dot product, you will operate what? I and I, j and j and k and k. So I and I, yes, I and I. So when you differentiate with respect to x, partial difference with respect to x, will get what? A1 only, na? When you differentiate this partially with respect to x, I'll get A1. Then when you partially differentiate this j thing with respect to y, I'll get what? B2. Yes. When you partially differentiate this with respect to what? Your z, you will get what? C3. So this is equal to 0. Yes, from this I can say that B2 is plus 2. Easy question. Easy questions. Like this, very easy question they will ask if you know these two conclusions. Understood these two conclusions? Very important. They have asked a lot of questions. From these two conclusions, they will ask a lot of questions. Now, there is something known as directional derivative. There is something known as what? Directional derivative, and then we will see the physical interpretation of the gradient. What is this directional derivative? dd, we call this as what? dd. The directional derivative is always with respect to a particular direction. Okay. The directional derivative of what? We always take the directional derivative of a scalar function. We'll always take the direction derivative of a scalar function about a direction. About a direction. Now when I say direction, any direction can be represented by a unit vector, na? Yes. Suppose that direction is having a unit vector of A. Okay, this is unit vector, right? Unit vector in direction of that particular direction, unit vector, right? So when I say directional derivative of a scalar function f, this is nothing but you take the gradient of f. Now gradient of f is what? Tell me, what is gradient of f? Gradient of f is a vector function, right? It's a vector function. Now take the dot product with that unit vector. This is nothing but the directional derivative of f about or along a cap. Understood, everyone? When I said directional derivative of f function, that is what? The gradient of f, which is a vector function. Now you can do what? You can do a dot product with the unit vector, right? This unit vector, right? Now if I say that in place of unit vector, suppose there is a vector given a. How to find a unit vector from this? How to find a unit vector from this? You take that particular vector and divide by what? The magnitude. You will get what? Unit vector. Yes, easy. Everybody understood what is directional derivative? Let us solve one question. Suppose the question is given that will find out the directional derivative of u. Use a scalar function. That means what? They will give a scalar function x square minus 3yx. So directional derivative of u, okay, along direction or about or in direction, either they will write in, along, about, like this they will use language. In, along, about, vector what? I cap plus j cap minus 2k cap. Yes, okay. Now this is certainly not a unit vector. It is not a unit vector, right? Now how to find out? This is the a vector. This is the a vector, right? Now what I told, the directional derivative of u, okay, about this direction will be what? It will be the gradient of u dot a vector, means unit vector along this. Now how to find out? This is the a vector, right? So I can write down gradient of u. Gradient of u will be what? Del u by del x I cap plus del u by del y j cap plus del u by del z k cap. Yes. Then what is the unit vector along this direction? This will be the a vector divided by what? The magnitude of a. Magnitude of a will be how much? Thank you, Jeet. The unit vector will be what? 1 square plus 1 square plus 2 square, 4 na. This is how you find out unit vector na. Childhood things, okay, which you forgot because you got some wonderful teacher in your engineering. Okay, so this will be equal to differentiate with respect to x. It will give me what? 2x, right? It will give me what? 2x I cap plus differentiate with respect to y. I will get minus 3z na, minus 3z I will get minus 3z j cap. Then differentiate with respect to z, I will get minus 3y k cap. Yes, this dot I plus j minus 2k divided by what? This will be root 6 na, root 6 na. This will be root 6 na. Yes, magnitude is root 6 na. Yes. Now it was given at a particular point. At a particular point means suppose the point is given 2, minus 1 and 4. Yes, 2, minus 1 and 4. See, this is a vector, this is a vector. So obviously at the end result I should get a scalar, right? At the end result I should get a scalar. So just put these values. So this is 2, so 4 I cap minus of 12 j cap minus or plus of 3 k cap. Yes. Then dot I dot j minus 2 k cap by root 6. How much are getting this value? Tell me. This will be 4 minus 12 minus 6 divided by root 6. A negative value. Minus 14 by root 6. How much are getting this value? Tell me. I'll check the answer. 5.715. I'm getting minus 5.715. I'll get a scalar, right? Understood this? I'll get plus 12. No, no. Understood this? How to find a directional derivative? Again, I'll repeat directional derivative. First, tell me, are you getting this answer or not? Then we'll solve another question, directional derivative. Getting this answer? Getting this answer? Very good. Getting this answer? Yeah. So, what is directional derivative of a function f? Directional derivative of a scalar function f about a direction of a vector a, that will be equal to the gradient of a f dot the unit vector along a. Yes, and this is equal to what? I can say the gradient of f dot the vector a divided by the magnitude of a. Yes, understood directional derivative? So if I give one question, okay, I'll give one question, okay. So the f function is given as xy square plus yz square plus zx square. This is the f function given, right? We have to find out the directional derivative about a vector v given as vector p actually. See, names don't matter, right? See, in place of a they give p, x, y, z, whatever, it doesn't matter, right? The concept matters. I cap plus 2 j cap plus 2 k cap, okay? And at we have to find out the point is 2 minus 1 and 1. Please find out this answer question. This was GATE 2018 question. Please find out this answer. Directional derivative of f. Grade of f, everybody is getting this? Grade of f? Okay, first find out grade of f. Yes? Yes, this is the grade of f you are getting? Yes? Then I will do this. 5 I cap minus 3 j cap plus 2 k cap I'll take the dot product with this p vector, okay, and then what I will do, I'll divide by the magnitude of this 1 plus 4 plus 4. Magnitude is 3 actually. So it will be 5 minus 6 plus 4 by 3. That is equal to 3 by 3. I am getting a value of 1. Understood? I am getting a value of 1. Okay? Understood this? See, very systematically you have to do these things. Very systematically if you do these things, you will be easily able to solve these questions. Okay, directional derivative. Clear? Very clear. Now what gradient of f indicates actually? The gradient of f indicates, see, f is a scalar function, right? F is a scalar function. F is a scalar function. Now there is another, any surface, any 3D surface is there. Any 3D surface is there, right? Any 3D surface is there. Yes, 3D surface is there. That will be a function of what? Any point will be a function of x, y, z coordinates, right? Okay. Suppose I am telling x square, y cube, z. Suppose this is the function, right? So any surface can be represented as a scalar function, right? Because any point on this can be found out using this, what? This value. We will take someday. This is vector. This is actually vector differentiation. Okay, I will tell you what to do. Don't worry. Okay, first focus on vector differentiation. We will see vector integration some other day. Okay. So this is what? This is the thing, right? Yeah. Now what gradient of f indicates? Gradient of f actually indicates the normal vector at a particular point of that particular surface. So if you take the gradient of f at a particular point, you found out, na? You are finding gradient of f, okay? You are taking the gradient of f, and this is the vector, right? This is a vector. See, this is a scalar. This is a scalar because the coordinate at a particular point will be a scalar. So this indicates what? This indicates the vector, normal vector. This indicates what? The normal vector, okay, perpendicular to the surface at a particular point. Perpendicular to surface. Perpendicular to surface. So what happens in the examination? In the examination, they might give you this question. They will give that there is a surface. Surface f is equal to what? Surface f is equal to, suppose they will give you x square y z plus what? Z cube y x yes, and plus y cube, okay, something like this. They give a scalar function, okay. Then they write a question. Suppose they write a question that find normal vector to surface at 1, minus 1, minus 1. What is the meaning of this? The meaning is very simple. The meaning is very simple. Just take the gradient of f and put these values 1, minus 1 and minus 1. You will get a vector, right? See, gradient of f will give me what? The vector, right? Yes, and that will be the answer. Understood this thing or not? I am not solving this question because you have solved so many questions on gradient, so I am not solving the questions. But you understood this concept or not? Instead of asking you the gradient, they will use this kind of language. They will use this kind of language. Or what they might do, they might ask find unit normal vector. They might ask what? Find unit normal vector. How to find out unit normal vector? Perpendicular normal vector to surface. That is very easy, na? You got the normal vector. This is the normal vector, right? What you do? This will be the normal vector divided by what? The magnitude of the normal vector. You can find out magnitude, right? Yes, yes, yes. For example, let us go back to our. Let us go back to this, where it all started. That is my mouse. I have a mouse also, no? Suppose I am going here. Yeah, this question, okay. I am going to this question, okay. So suppose I am telling that this is the surface. Suppose I am telling this is the surface. and I asked you find out the normal vector at this point. So this becomes what? The normal vector. This becomes the normal vector, right? This becomes the normal vector to the surface at this point. If I want to find out the unit normal vector, if I want to find out what? The unit normal vector will be what? You take this vector 2y cap plus 12j cap minus 4k cap divided by what? The magnitude. Magnitude will be what? 2 square 4, 12 square 144, and 4 square is 16. So how much will get? This is root under 164 na? Root under 164 na? Yes. I'm going 12.81 something, right? So this is, I can say 2 by 12.81 I cap plus 12 by 12.81 j cap minus 4 by 12 by 81 k cap. See, either they can, give options, na? They will give you options, don't worry. Either they might write in this format, or root under 164 is what? It is actually coming 2 root 41. Sorry, hiccup came because I have not taken water from long time. So root under 241. So in this format also they can put, right? Or they might write this as what? They might write this as what? I cap by root 41 plus 6j by root 41, and this is minus 2k cap by root 41. Understood? So everybody understood what are types of question they can ask in vector differentiation. These are all the questions from vector differentiation. Okay, so many things I taught you today. Okay, all related to what? Your curl, divergence, yes, and all these questions can be asked in the examination. Now how to complete the rest of the vector calculus? Yes, so I will tell you how. See, in BYJU'S Exam Prep app, if you go to BYJU'S Exam Prep app, okay, so there we have recorded lectures, learn with video lessons, nicely animated lectures are there. Okay, there you can go to engineering mathematics. In learn with video lessons, you can go to what? Engineering mathematics. So when you go to engineering mathematics, lot of chapters will open. Okay, so there you can go to vector calculus. Here you can see all the important topics like vector differentiation, gradient and properties, directional derivative, divergence and curl, all the vector identities. See, I just told you 3-4 prominent ones. There are more 10 to 15 ones, right? So vector identities. Then somebody asks about integration and volume integral, surface integral. So you see line integral is there, surface integral is there, and volume integral is there, right? So everything about your vector calculus is nicely covered. Okay, nicely covered, and all these videos, you can see all these videos, all are 30 to 40 minutes video. They are not long lectures. Maximum is 45 minutes around. Okay, and all these lectures are done by our very dear Sridhar sir. So Sridhar sir is very experienced faculty. Okay, so he has taught for more than 20 years. Okay, he is in GATE and ESE domain for last 20 years. Even I have learned many of the concepts of mathematics from him only. Yes. Okay, so he is a computer science faculty and a very prominent faculty of engineering mathematics. Yes, so sir has recorded all these videos not only for vector calculus. Here I highlighted vector calculus because today we discussed vector calculus. Okay, so as I told that there are more identities also. I discussed only a few important ones because GATE exam is near. Okay, so I just discussed the important ones. If you cover this much also, it will be beneficial. But if you want to cover more, yes, especially vector integration and all, so you can visit these lectures. Okay, and you can clarify your concepts. Okay, so next is what? Today only 9 PM I will be taking a class on fluid mechanics in the exam prep app. So you can download the app. On the app I will be teaching you fluid mechanics, and today we will be studying pipe flow. So exactly after 1 hour 20 minutes we'll study pipe flow. Yes, so pipe flow I will teach on the app sharp 9 PM. So those who students want to attend, they can come. Okay, yesterday we discussed the whole hydrostatic forces in 1.5 hours. So today I'll try to cover pipe flow. in 1.5 hours and so. Okay, and today 10:45 p.m. Joshit sir will take, okay, the most expected questions on what? Your transportation highway engineering. This is part 1. Today he will take the part 1, tomorrow he will take the part 2. So please attend that. So you can attend at 9 p.m. you can attend Pipeflow on the app. At 10:45 you can attend in the YouTube channel. This will be on YouTube only. Yes, YouTube. And then tomorrow, important announcement. See, when you're preparing for GATE, I always tell that you indirectly prepare for all the state examination. But when you're preparing for state examination, like Telangana Public Service Commission, or you're preparing for what? Your Jammu and Kashmir Public Service Commission. Okay, I am always on, many times I'm coming. You can subscribe to the channel, Mr. Yadav. You can subscribe to the channel. If you subscribe to channel, you'll get the notification, right? And then suppose you are appearing for UPPSC, okay, or you're appearing for any examination, see, all the exams, what happens? All the exams syllabus is less than equal to what? GATE. So if you're preparing for GATE, obviously all the examinations, okay, BHEL, HPCL, whichever exam we are talking about, everything is covered under that. Yes, and you don't have to prepare separately. Yes, but you have to practice questions, because in GATE questions are little, we can say, more numerical and more lengthy compared to the public service commissions, even if the concept is same. So therefore regularly I am coming up with these practice sessions. So tomorrow we'll be solving 15 MCQs, and these 15 MCQs will be what? Will be relevant to GATE 1 mark questions from open channel flow only. Okay, open channel flow only. Okay, and this will be beneficial for your ESE prelims examination. It will be beneficial for your SSC JE also. It will be beneficial for your UPPSC also. It will be beneficial for TSPSC, because many students think that I have to prepare something else for TSPSC. Yes, for SSC JE, same thing. Okay, if you ask me from tips, I will tell you that please cover all the previous year questions of mains. In SSC JE mains, cover all the previous year questions. Every questions of previous year should be on your tips. So you buy a previous year question booklet of SSC JE and solve all the questions. That I can say. Okay. So for such all examinations, we will be conducting this MCQ series. So I have conducted for strength of material for many subjects. So tomorrow at 10:30 AM, okay, you revise today, or if you have not revised, no problem, please join AM morning. So there we will be solving questions of what? Open channel flow. 50 questions I will solve. Okay, 50 questions I will solve. Okay, and it will be solved in 1.5 hours. So in 1.5 hours, your 50 questions from all the different examinations of, we can say different examinations and different portions of open channel flow will be covered. Okay. So great, thank you very much. Okay, I will again say that those students who want to regularly attend the sessions, I will request them to, not request them, I will guide them to say that please subscribe to channel. You can see that the link is available. Okay, please subscribe so that you get the notification, and every morning you can see the community section, you will see the list of lectures. Or if you want to get some more notification, in the description if you go, there is what? There is the link for Telegram group. Okay, the Telegram group is for civil engineering students. Okay, and for mechanical also there is another Telegram group. So join the Telegram group. In the Telegram group, daily you get the notifications and the required links. So if you are in the Telegram group, automatically the link will be there. Okay, so then you don't have to visit the channel always. Okay, and if you subscribe, what happens? If you subscribe to channel, so what happens? Automatically when you open the YouTube, whatever lectures have been taken today or will be taken will be visible on your YouTube page also, home page. So please subscribe to the channel also, and you can subscribe to the Telegram group also. Okay, and thank you very much. Nice. We'll meet the next week with another topic for practice for engineering mathematics. Okay, and if you want some particular topic to be covered of engineering mathematics like this, the way we did today, like in 1.5 hours we completed many of the most probable things, you can mention in the comment section of this particular video. I will take that particular topic. Okay, then thank you very much. Bye.